Alright, so we're going to take a look at absolute values when they play into inequalities now. One thing I want you guys to notice for sure is when we have the absolute value is less than a, that goes with the conjunction. Now, when we're graphing a conjunction absolute value, that means that everything is going to be between bars. Okay, so if you ever have an absolute value inequality problem that looks like this, it's always going to end up being graphed where the line is in between your dots. Now, second case, if your absolute value is greater than whatever number you have going on there, that is a disjunction, and a disjunction means that you're going outwards. Okay? So keep that in mind, and that's just what this next slide says as well. So if you have the and, that's one thing that means conjunction. The or means disjunction. So you can see these examples. Make sure that you get that piece in your notes because that is so important. And it's super easy to forget. And it's super easy points if you can remember it. Okay, so keep those two things. If the absolute value is less than or equal to a number, you're always going to be going inward like this. Or if the absolute value is greater than or equal, you're always going outward like that. Okay, so let's jump into an example. This first one, we have the absolute value of x minus 5 is less than or equal to 2. So you'll notice for all these first ones, we're going to be dealing with conjunction. So if we were to graph all of them, they would all be going inwards. But we will see what we get here. And then another thing with absolute values, so when I drop the bars here, so the first one I'm going to write just as is, and now the second one, I'm going to say x minus 5 is greater than or equal to negative 2. So there's two things that I did there. I flipped the sign and I flipped the inequality. Okay, so flipping the sign, making it negative, and flipping the inequality. So the next step in solving, I'm just going to have to add 5 on both sides for this first one. So I'm going to get x is less than or equal to 7. Then I'll add 5 on this other one. So I'll get x is greater than or equal to positive 3. So I could write these two things together and they would read like this. X is greater than or equal to 3, but it's less than 7. So that x is squeezed right in between those two numbers. So if we were to graph that, I'd have 7 and a 3, and my values are going to be right in the middle of there. Notice I filled in the dots because I had the less than or equal to or greater than or equal to. Okay, so there's the first one there. Next, just like our equal signs, we need that absolute value to be alone before we can evaluate it. So I'm going to say minus 4 on both sides. So that'll leave us with negative 2, absolute value of 3x, and that will be greater than or equal to 2. Next step, get rid of that negative 2. Now, I'm going to flip the sign. Now that would make it a conjunction. However, we're ending up with negative 1. So it doesn't matter what x is, an absolute value will always be negative. So if I have the absolute value is going to be less than or equal to a negative number, that's always going to be false. Okay, so that means that whatever I have for x, that's going to be no solutions for this problem. And this problem is just done where it is. I can't go any further. Okay, now moving on to disjunctions. So disjunctions, remember, is we're going the opposite direction. Now, again, I'm just going to drop the bars right away because we can see the problem right there. And the first one is exactly the same. Then I'm going to have 2x minus 5 is less than negative 9. So I'll solve this first side, add 5 to both sides. And we get 2x is greater than 14. And I will add 5 to the other equation. I get 2x is less than negative 4. divide by 2, all the way across. Now I get x is greater than 7, and I get x is less than -2. So I already know it's a disjunction, so I know what direction that I'm going here. However, we'll just think of it anyways. So if you have x is greater than 7, that needs to go that way. Think of a number greater than 7, or x is less than -2, like -3 would work, so that's a true statement, and that's how we do a problem like that. Now, let's take a look at this one, because this is important. So if I divide by -1, divide by -1, get the absolute value of 4x minus 2 is greater than -1. Now think of that statement. So we know that an absolute value will always be positive. So that means if this is always positive, then whatever that x is, even if I have a 0, because I would still have that -2 absolute value, -2 is +2. So it doesn't matter what x is, this will always be true. So we have infinite solutions here. And it's all because of the direction of that inequality. So because the inequality or the absolute value piece is greater than a negative number, we get infinite solutions. If the absolute value is less than a negative number, that would be no solutions. Okay? Almost done with this lesson. Thanks for being patient, guys.